Hi, I'm going to show you how this recursive solution works line by line for this problem. So we need to find the maximum depth of our binary tree. Each one of these nodes represents one level. So 1, 2, 3. And the farthest leaf simply means the node that is lowest down in the tree. And a leaf is a node that has no children. So there's nothing beneath this, so it's a leaf node. Here's the solution. We have a function called max depth. It takes in a parameter called root. We check that root. If the root equals null, so if there's no root or if it equals null, this is what this check does. It returns 0, the number 0. Otherwise, it returns 1 plus math.max, which takes the larger result of these two inputs. And in this case, we're recursively calling the max.depth function. So it's going to take the larger number between the result of these two. Okay, let's step through our solution one line at a time. The first time max depth is called, we are passing in our root. In this example, root is 3, our first node. So root is not equal to null, so we do not return 0. Instead, we move to the next line and we return 1 plus math.max. Math.max is a function that returns the larger value between these two, which means both these functions have to return a number, okay? And this entire max depth function is always returning a number, and it's taking in a tree node, which in this case is named root. Okay, so that means we have to go through this line. Root is equal to 3. We're at root, and it's our first step. So return 1 plus math.max, and the max depth function is going to be passed in root.left. What's to the left of our root? The node 9. So this value is going to become 9. And there's another part too to our math.max function. It's the right side. So we have to check the right. So we do max depth again, but we pass in the right node. What's to the right of 3? 20. But hold up, we're not going to actually execute this function for a while. We have to go through first and check all of the left nodes. And let me explain what that means by using this line. Okay, so first we're going to check all the left nodes to the left of our root. So here's our second line, our second execution. We're checking the left. Root is equal to 9, so we're checking this. We return root's not equal to null, so we go to the next line, return 1 plus math.max. For, again, we need to update. Root is now equal to 9, so we have to check to the left and to the right. What's to the left and right? Nothing. 9 is a leaf node, which means we put null here. Okay, so the next two lines that happen are these. Okay, the third step is we're checking to the left, and root is equal to null. So in this case, we just return 0, which means this equals 0. And then we go to the fourth line. We finally do the right side. We check it. We're checking to the right. Root is equal to null as well. And it also returns 0. Awesome. So now we can finally do the arithmetic for this entire line. So here we go. We have return 1 plus math.max for 0 plus 0, which equals 0. So this equals 1. And now we need to check the right side. The order of these two parameters is very important. Because this is the dot left property on root, it means we're always going to check to the left first, and we're only going to check to the right after the left has returned 0. Okay, that means we got to the end of the left, then we finally check the right. In this case, right was also null. But what I mean by first right here is that we finally got to the end of our left node, and we're now going to check the right. Our fifth step finally checks the right node. So we're going to execute this function right here, max depth 20. Root is 20. It's not equal to null, so we skip over this and we return the second line. 1 plus max dot math.max for max depth 15, that would be root.left of 20, and max depth of 7, which would be root.right of 20. But remember, we're not going to check right until we check all of left. So that means our sixth step is going to be this one. So we're checking the left, and root is equal to 15 now. So we go through, and what's to the left of 15? Null. What's to the right of 15? Null. So we do those two lines again, which we end up returning 0. So the left is equal to 0. The right is equal to 0. So we can do the arithmetic for this one, finally. So we return 1 plus math.max for 0 and 0. Which one is larger? 0. They're both the same. So this equals 1, which means max depth 15 returns 1. All right, perfect. So that means we finished on the left. Let me move that. We finished on the left. We checked the right too. So we have to go back up here, and now we check the right of 20. So the next line is this one, the ninth step, root is equal to 7. Okay, and what happens here is the same thing. What's to the left of 7 and what's to the right of 7? Null. So the 10th step returns 0. Left is equal to 0. And the 11th step returns 0 as well. What's to the right of 7? 0. We can do the arithmetic, return 1 plus math.max of 0 and 0, which means they're both equal to 0. This again equates to 0, so we can move up to here, root 7. This function is equal to 1. And we can do the arithmetic for this now. So we return 1 plus 1 because 1 is the largest number inside of here, and that's equal to 2. And that means root 20 up here is equal to 2. Now we can do our final arithmetic. So we return 1 plus math.max of 1 and 2, which is equal to 2, right? It's larger, which means our entire function returns 0, and that is our answer.